Hey everyone, so today we're going to go over quite a bit because I noticed some common learning opportunities on both the quiz and the homework, and I want to talk about the project ideas you submitted at the end. But let's start with the quiz. So this is the data that you were given, and the first step was to find the covariance. And you need the mean of each data set to do that. So let's start by just doing the mean, which if you do this in Excel, the function is average for each. And then we need a list of all the deviations for each. So I'm going to take this, minus this, sticky that. Oops. Forget the shortcut for sticking on this keyboard. I think it's, there we go. Okay. So I'm just taking each data point and subtracting the mean, right? And we have two variables, height and weight. I'm doing that for each of them. So this minus its mean, I'll sticky it. And the sticky, if for those of you unfamiliar with Excel, just ensures it doesn't change as I drag. So see here, I'm still subtracting the mean because I stickied it with the dollar signs. Okay, so now I have a list of all my deviations. These are height deviations. Might as well label them to avoid future confusion. And these are weight deviations. And you probably remember from, I don't like how this, there should be like a wrap text or something. Let's see if I can find it. But you should remember, while I look for that, that or we'll just say W deviations is a clear label, and then we don't have to worry about it spilling over and making the row longer. Okay, so you should remember the formula for covariance is just the sum of the product of the deviations divided by the sample size minus 1. So here's my deviations for height, here's my deviations for weight. My product of them is just as simple as 1 multiplied by the other. Now you could wind up with negative values as you see in the height deviations and weight deviations. You could wind up for negative values here too, but in this case we don't. And then you just sum them all up. And lastly, divide by n minus 1. N in this case is 5, so n minus 1 is 4. Right? And this is what you should have gotten for covariance. And this question builds on each step iteratively. So if you get one part wrong, but did the process for the next part correctly, I did give you credit. A lot of you had rounding errors. The way to avoid those is don't take a rounded answer and use that in your calculation. Always use unrounded answers in all your calculations. And then once you've gotten your final answer that you're ready to submit, round that answer. And then if there's a future question which uses that same metric or statistic, don't plug in the rounded one, plug in the unrounded one. But I did give you guys all back points if it was due to rounding error. So this is our covariance, like I said. So how do we go from covariance to correlation? We just divide by the standard deviation of each. And we talked a little bit about the intuition behind that, right? Variance is in the units of your observations squared. So a variance divided by a variance is unitless and therefore easier to interpret. And you could think of two standard deviations being multiplied together as a sort of variance. So let's find the standard deviation of height and the standard deviation of weight. You probably remember it's going to be equal to the sum of all of these things squared. Which actually maybe I can't do in one line. So let me do h dev squared here and w dev squared here. So I'm just going to square each of these, and I'm not going to use any stickies because I want it to change when I go to weight as well. Okay, so now we have, and if you double click on it, you could see the cells it's referencing. So just squaring everything. Now everything is positive. I can sum them all up, right? But that's not quite my standard deviation, right? It's not even my variance yet because I still have to divide by 4. Now it's my variance. Oops. Now it's my variance. To get the standard deviation, all I do is take the square root. So we just wrap these guys in a square root. Okay, so if I take this, which I should label these, right? And this is the standard deviation for height. I'll just call it like that. This is the standard deviation for weight. And this is my covariance of height and weight. So I know there's a lot of numbers on here. Hopefully the labels help make it more clear. So now to get my correlation coefficient R, all I do is I take my covariance and divide it by these two standard deviations. And a lot of people asked, well, does it matter the order? And the answer is no. So you could do this the way I did with 2 divisions, or you could do this by multiplying the 2. And you'll get the same answer because the order of operations, multiplication and division are commutative. So, like multiplying by half and multiplying by half again is the same thing as multiplying by a quarter, right? So here we have our correlation coefficient. If you want to round it for that answer, that's fine. But notice I use the unrounded values in calculating this. And then there's another question, which is what's the coefficient of determination, also known as big R squared. And that's a really easy calculation because you just take your correlation coefficient and square it. But notice I'm using the unrounded correlation coefficient. And then I can round, the final answer before I submit it. So those are the steps to take to get all of them. On the last question, a lot of you had the right intuition. There is no best statistic, right? There's a reason that there's a lot of statistics available to you. I was really looking for you to justify. There's 3 statistics we calculated here, right? There's covariance, 23.1. There's R, the correlation coefficient, 0.98. And then there's R squared, the coefficient of determination, 0.96. Which of these is best really depends on the criteria you're using to evaluate them. And you could have said anything and gotten this answer correct if you justified it. And I was really looking for you to justify it relative to the other 2. So, when somebody asks you a question about what's best, you don't just want to say, well, this one's the best because X. You want to say, it's better than the other options because, option 1 has this limitation, option 2 doesn't, so forth and so on. So I'll start with my opinion. And again, there is no right answer. So this is not, my opinion is not necessarily correct. And then I'll share with you the other, I think, valid opinions as to why you could have picked one of the other statistics. So I do like the correlation coefficient best. And the reason I say that is 2 things. First of all, and a lot of you did point this out, it gives you the direction of the relationship. Is it a positive correlation or a negative correlation, which the coefficient of determination fails to do, right? It just tells you how strong that relationship is, or more specifically, the amount of variation explained in one variable explained by the other. So I like that it gives you direction, positive or negative. But covariance also gives you direction, positive or negative. You could wind up with a negative covariance, right? You'll never wind up with a negative variance because of the squares. But like here, you could see there's some negative numbers, and if one's negative and one's positive, you could wind up with a negative covariance. So that also gives you direction. But the reason I prefer the correlation coefficient is because it's less work for me to interpret, because it's unitless. It's been standardized in such a way that there's no units, and it just ranges from, yes, -1 to 1, but in terms of magnitude, 0 to 1. And I know the closer it is to 0, the weaker the relationship, the closer it is to 1, the stronger the relationship. So it's really easy for me to hear a number like 0.98 and know, wow, that's an incredibly strong correlation, right? You never see that in real life. This is obviously fake data that I made up, and that's one reason why it's so strong. On the other hand, with covariance, you have to think in terms of the units. Well, 23, what are we talking about here? Well, we're talking about feet and pounds. So it's even hard for me because there's two units going on here, feet times pounds, to know if, what the relative interpretation is behind 23. So it's a little more work to get at what the meaning is there. That said, that's just my preference. These are also valid answers. So some people said the coefficient of determination, and I think the justification that was strongest for that is it gives you something that none of the other metrics do, which is the percentage of variation in height explained by weight, or the inverse, the percentage of the variation in weight explained by height. You could think of it either way. It's just a matter of which one you label as independent and which one as dependent. So it does give you an interpretation that you don't get from the other two variables, and I think that's a good justification. And as far as covariance, you could say, well, this one's like the easiest to calculate, right? Because you're calculating them iteratively, right? Correlation coefficient builds on covariance. Coefficient of determination builds on correlation coefficient. So like this is the least work to calculate. In addition, it gives you the direction of the relationship, and it gives you a measure of how these variables, height and weight, vary together. You have to think a little more to understand what that 23 really means, but it is a measure of relationship as well. So some people, more people than we would want by the end of this course, said something along the lines of like, I like the correlation coefficient because it measures the relationship and the strength of the relationship. All three of these statistics measure the relationship between these variables. They're all doing that. So again, it's really important when you're given a question like, what's best, to frame it, like mention your other options, like what makes it better than the other choices. And again, there is a lot of subjectivity involved, and I think, it's perfectly reasonable to pick any of the three, but I was really looking for a justification that talked about the statistic you chose relative strength to the other statistics. Okay, so let's talk about the part of the homework in JUMP. So most of you did this pretty well, and there are just a few comments I wanted to make as far as like some potential areas of improvement, and we're just going to walk through not both questions because it'll take a while, but let's start with MLB. So this one was pretty easy, right? You go to Graph Builder. Hopefully you've learned this by now and you're not just blindly following the steps, you're trying to do it on your own. And if I remember right, apologies if I'm remembering wrong, I think it was runs and hits that we want to make a scatter plot of, and a lot of people made this mistake. They said, there's my scatter plot, and that is not this. First of all, these are side-by-side scatter plots, right? You have runs being plotted here, but hits is for some reason a categorical variable, and it should not be. It's a quantitative variable, right? So you have to force it to behave as a quantitative variable, and we're going to do that by saying, actually, this didn't happen to me last time, so let's see how we can flip this around real quick. Transform. Let's see if rounding it works. Yeah, let's see. No, that didn't seem to work. Oh, that was runs, not hits. My mistake. Let me delete that. Did not want that. So let's see what's going on with hits. Let's see if rounding it works, although you don't necessarily need to round it, but let's see if that helps. No, we still have this scatter plot. Okay, so this is helpful for me because now I'm seeing like how you guys wound up with this. Let me try moving it again. Yeah, for some reason it's Okay, so levels is speaking to the fact that it is turning it into categorical. Let me try clicking here and seeing if that helps. No, because it's just creating it. Huh. Okay, so I'm starting to see the issue that you guys had. Let's see if we could figure out what's going on here. Because they are both quantitative data, but it's being treated differently. Let's try again, start over. Hits, and then what was the other one? Runs. There we go. Okay, and I realized what the issue was now, and it was good that we're doing this live and you could see me make the same mistake. So I think what the issue is if you drag hits over to group Y, it will automatically turn it into a categorical variable because a grouping variable has to be categorical. So you want to make sure you drag it over to the axis that represents where you want to plot it. So I know it's a little confusing because you see 4 axes here. Let's just start over. X, Y, group X, and group Y, right? And each of those axes behave differently. I think the key thing to keep in mind with a grouping variable, sometimes referred to as a facet, is it is categorical and it is going to create either multiple plots or a color dimension splitting the data on the X and or Y axis by that group. So you'll actually see it. We'll do the second question too. But that was the mistake that I'm realizing now why a lot of you made. You wanted to just do hits and runs like this. I forget the order of which one was Y and which one was X. But by default, it does a smooth curve. We don't want it to be a smooth curve, right? So we just toggle over to line of fit, and you get your regression line with the confidence interval around it in terms of a likely range of where that line could live. So that was the first mistake. Then let's go over the second common mistake was not this data set. So let's open the new data set. Right, and we'll go to graph builder. So in the first question of this data set, right, and here you want to use a grouping variable, thinking about how things are going. So this is a general, the entire data set, or is it the country going in the right direction or the wrong direction? We want to split this by party. So because we're splitting this by party, it is a grouping variable. And I'm going to put it, since this is on the x-axis, I'm going to use the group X, not the group Y. And it splits it, right? And a lot of you had pretty good intuition that this is kind of easier to see in a bar chart, but specifically what I was looking for is a stacked bar chart. But first let's do it the way that the question phrased you, which was to make separate pie charts. And most of you did this correctly. Some of you did not include the legend, which is really important here. If you don't include the legend, at least include labels in the pies, or else I don't know which slide corresponds to which one. And I would move the legend to be down here or something to be more clear. And I think that's what I put in the steps. But this is what we were looking for. So the trick here, which I wanted you to see in the hint, which hopefully most of you clicked on, was this kind of graphic, which is difficult to make in JMP. But it's a stacked bar, and I think it conveys the information better than 3 separate pie charts. And you can see it's colored by the responses, and then you have party on the y-axis. So the hint was kind of a giveaway if you did see it. Lastly, I just wanted to talk about the project. So first of all, great job. I can tell that the research questions you picked are things that you're genuinely interested in, and that's great. That was the goal. I want you to pick stuff that you're curious about, that you have some passion in, and that makes the work more tractable for you to spend time on. Some of you had really good ideas but did not identify a data set. They just said something vague like, I'm going to look online for this sort of data. And I think you might be underestimating how difficult it can be to find an appropriate data set to answer your research question. And some of you also shared that you're going to be collecting the data yourself, either through surveys or through experiments you're conducting. If that's the case, start your data collection early, because if it comes to be the last week of class and you find out that you don't have your data yet, you can't do your analysis, it's going to put you behind, and we want to avoid that as much as possible. So start your data collection now if you are collecting data, either through survey or experimentation. Similarly, I want you to be mindful of the issues we talked about, potential issues that could occur with survey and experimentation in the data collection process. So there's limitations to that. Some questions to think about in identifying the limitations is my sample going to be representative of the population? Yes, randomization helps. Yes, stratifying or blocking helps. Yes, a large sample size helps. But even applying all of those principles, you could wind up with a sample that's not representative of your population. And it's important to mention any limitations that you're aware of in the data collection process. Similarly, I want you to be thinking about biases. We talked about a lot of different kinds of bias in class. So some of you, for example, are using self-reported data. There's a huge assumption that goes into self-reported data, which is you're trusting the person reporting to that information to give an accurate measurement. And that doesn't necessarily mean that people will lie and say something inaccurate. It could be that they don't realize they're giving inaccurate information, and it's just something to note. And I'm going to make all of these points more clear in the rubric and instructions for the project. But in your write-up, we talked very early on in class about that word mathematization, taking a real-life situation and turning it into a math problem. And it's very important that you list out all of the assumptions you make in doing that. So this does address, limitations, potential biases, and so on, so people can interpret your results appropriately. And I'm looking for you to do that. Another thing I wanted to mention was a lot of you chose interesting research questions for which there's existing research. And that's fine. A lot of research is based off existing research. It's building on it and adding to the body of knowledge in that area. Good practice, though, is to cite existing studies. And I'm not looking for anything fancy, but do mention in your introduction and background, there has been prior work here. These are the results. And then go into how your study is a little different, or how it's building off of the previous results found. Or if you're just confirming previous studies and you were just curious and wanted to do it yourself, you could say that too. But it is important that you cite prior related studies in the field. And it's really easy to do that. You could search on Google Scholar to find related studies by keyword. Typically, the results are ordered by the number of citations. The more citations a study has, the more influential it is, the more viewed it is. So that's in one way to find some related studies and share that in your background. The last thing I wanted to talk about in the project is related to multivariate regression. So the content for this class goes up to bivariate analysis, meaning you're comparing the relationship between two variables. That's as far as the class goes. That said, the last week of class, there will be optional lectures on multivariate regression. Without going into a ton of detail now, the idea behind multivariate regression, and we did talk about regression and fitting the line in previous slides, but multivariate regression, as you can imagine, is with multiple variables. And one thing you can do with multivariate regression, again, without going into a ton of detail now, is you can look at the effect of a variable holding all these other variables that you believe to be influential to your response constant. So one example is people were interested in analyzing, this is one example I'll share because a couple people had a similar idea here, analyzing the level of education that students go on to receive or how successful they are in their educational career based on parental income. And they know there are other variables related to that, right? So those other variables could be things like GPA, or I don't know, another related study was like parental education level. And you want to isolate the effects of those variables from the effect of parental education level, or income, parental income. So you fit all those variables in your regression model, and then the interpretation behind parental income, the beta for parental income is this is the effect of that variable holding these other variables in the model constant. It does vary based on whether the data is categorical or not, and we'll go into more detail about this when we cover multivariate regression. But the reason I bring that all up is to say, if you're interested, the last week of class is going to be optional as far as the lectures go, and we will be talking about multivariate regression in more detail then. If you're interested in doing this kind of analysis with more than two variables, watch those lectures, meet with me, and we can build an appropriate model to answer your question more completely. Okay, so just wanted to share those thoughts on the homework, and looking forward to seeing all of you next week.